that was like a joke.
Okay, here we go. 10, 14, 19. Okay. We are doing some more solving. This whole chapter 1 is all about solving all kinds of equations. It's kind of ridiculous. And so you know how to solve linear and quadratic equations. So today is just an extension of that. But they're all rational equations, and I'm going to teach you the shortcut method. We've talked about multiplying through by the LCD, which it's fine. It works. And it's technically what we're doing, mathematically speaking. But I'm just going to show you the shortcut. And that is logic. So I gave you these two questions here because I wanted to know, well, on number 1, what's x? How did you arrive at the answer of 12? I heard two things. I heard two things. I heard cross multiply. I heard 3 things actually. I heard cross multiply. If you cross multiply, you get 7x equals what, 84, and then you can divide by 7 and you get x equals 12, right? You cross multiply. I heard multiply through by 7, which would be the LCD method. You multiply through by 7. Sure, same as cross multiply. Okay. But take a step back. That's the highly procedural way of doing things. Not incorrect. It's perfectly wonderful. But can't you just look at it and say, yes, it must be 12 by the definition of equality? Yeah. For 2 things to be equal, they must be identical, right? Okay. So, and then here. So keeping that in mind, this is the definition of equality. What must x be? 7. Okay? Because if the denominators all match, do I have to worry about them? No. Which is where math gets interesting, okay? Because there's so many ways to do it that are completely accurate, but they take more time, okay? So today, we have equations like this. And today, the rule is, if the denominators all match, then I don't have to think about them anymore because they're already equal, okay? So there's no need to cross multiply. There's no need to multiply by the LCD. If the denominators match, I don't have to worry about them, okay? So just like this, the denominators match. I don't have to worry about them, okay? All right, so here we go. I hate it. Yeah, so slightly harder. Okay. Slightly harder. Okay. All right, example 1, solve each equation and check. You absolutely need to check your solutions. Keeping in mind that these are rational fractional equations, and remember, we're not allowed to divide by a 0. So we want to pay attention to what makes those denominators 0. So we'll be paying attention to that for sure. So the rule is factor first. Factor, factor, factor. And by factor, I mean factor denominators. Factor first. Factor first. So I have... what can I do with this denominator? 3n plus 6. Pull out 3, sure. So I have 2 over 3 times the quantity what? n plus 2, that's better. Okay, good. We have a subtraction sign there, and then I have an n plus 4 in my numerator, and my denominator here is going to double bubble. N times n is n squared. What times what is negative 10? Negative 5 and a positive 2. How do you know if you did it right? Check the rainbow. Very good. Don't forget about the lovely rainbow. Okay. And then that's supposed to be equal to 3 over n minus 5. Does n minus 5 factor? No, it does not. So it's its own factor. It's prime, so to speak. Okay. All right. So what I want to do first of all, is figure out what are the exclusions. What is x not allowed to be? Or in, rather. -2 and +5. Very good. Okay. So right off the bat, n is not allowed to be -2 and +5. Once you factor, go ahead and figure out what n is not allowed to be. Okay. Really important that you do that right off the bat. Now, what I want to do is make all the denominators match so that I can not have to worry about them. So let's look for what we have in common. What do I have? What's one factor I have in common? n plus 2. N plus 2. All right. So I got a couple of n plus 2's, but over here doesn't have it. So what do I need to do? Put it on there. Yeah, multiply, n plus 2, top and bottom. Multiply by n plus 2, top and bottom. Okay, so now, right, we've got the n plus 2's on every fraction. What else do things have in common? Okay, n minus 5 and an n minus 5 on 2 of those, which means this first one needs one, right? Okay, so I'm going to multiply by n minus 5 on top and bottom. All right, so now every fraction has a green and a purple. What else do they need? 3. Yeah, we have a 3 that we need to take care of as well. So I'm going to multiply by 3 on top and bottom for a couple of times here so that everything has a pink 3 and a green n plus 2 and a purple n minus 5. Okay, now that all the denominators match, I can forget about them. All right? So I can get rid of those denominators, and I'm left with just my numerators, 2 times the n minus 5 minus 3 times the n plus 4 equals 9 times the n plus 2. What do we want to do? Distribute. We've got a lot of distributing to do. So we're going to distribute our 2, and what does that give me? 2n minus 10, and then I'm going to distribute my -3. What's that going to give me? -3n minus 12. Very good. And I'm going to distribute my 9, and that's going to give me 9n plus 18. Okay. All right. So that's kind of nice, right? Pretty nice. Okay. So there were about 15 steps that you could have done. Okay. Which means that these have common denominators, so you could have combined the numerator, and then you could cross multiply. The denominators would cancel out, but you don't have to, because ultimately they'll just cancel out. So kind of nice. We can just cancel out those denominators. And now I'm going to combine like terms. 2n minus 3n is -n. -10 and a -12 is a -22. Equals 9n plus 18. I'm going to go ahead and add the n. So I'm going to get 10 n's plus 18. And I'm going to go ahead and subtract 18, which I can't do in my head, evidently. 30, 40, -40. And so n equals -4. All right. Is that okay? Okay. All right. And it's a good thing that n didn't happen to equal -2 or 5, because it was not allowed to be that originally. Okay. Letter B. I have m over m plus 2. Does m plus 2 factor? No, it's prime. It's its own factor. -3 times, what about m plus 5? Does it factor? No. It is prime. And then is equal to 9 over, now this one does double bubble. How does m squared plus 7m plus 10 factor? M plus 5 and m plus 2. Very good. So right here, I'm going to go ahead and say, hey, what's m not allowed to be? Good. Right off the bat, let's just understand our denominators are not allowed to be 0. So I know I can't have answers of -5 or -2. And now I want to look at what they have in common. I want to make my denominators match. So what's in common? M plus 2 and m plus 2, which means this middle fraction needs an m plus 2 on top and bottom. All right, so now each fraction has an m plus 2. What else is in common? Got a couple of m plus 5s, which means my first fraction needs an m plus 5, so it can have the green factor, m plus 5, on top and bottom. So no, all of our denominators have the same purple and green factors. And so now the denominators match. What can we do? Ignore them is the best part. It's like completing a list. Crossing something off your list. Doesn't it just feel good? Okay. Sorry, maybe that's just me. So I'm left with m times m plus 5 minus 3 times the m plus 2 is equal to 9. And then what do I need to do? Distribute. What's m times m? M squared plus 5m. And distributing the -3, we get minus 6 equals 9. Now, what's the difference between this first equation and the second equation? It's, m squared. This first equation, L-A-N-E-A-R, turned out to, we call this, it resolves to linear. Resolves to linear, meaning it's into the first power, okay? Where this one turned quadratic on us, okay? So this one, because it's being squared, this is a quadratic equation. So linear equations, easy to solve. How do we solve quadratic equations? Double bubble if you can, which means it needs to be equal to 0. Yeah, so I'm going to move my 9 over, and I'm going to combine some like terms here. So I have m squared plus 2m's, and I'm going to subtract the 9, so that's going to give me -15 is equal to 0. So for all your quadratic equations, you want to make sure that it's set equal to 0. And you can either factor or use the quadratic formula. Okay. So I think we can double bubble here. So m times m, what times what is -15? +5 and -3. Good. Which means m equals
3 and -5, except it's not -5.
Very good. M is allowed to be 3, but it's not allowed to be -5. That is what we would call a false solution. Okay. We knew that we were not allowed to be -5. Okay. Okay. Questions on either of those? All right. So one more. One more just for giggles. All right, letter C, we have 2x over x squared minus 4x plus 3 plus 3 over x squared minus x minus 6 equals 2 over x squared plus x, God bless you, minus 2. All right, the rule is factor first. One of my favorite alliterations. I think alliteration is totally cool. Peter Piper picked a peck of pickled peppers. Oh my God, it's awesome. She sells seashells down by the seashore. Okay, it's close.
Well, if you remember thing, I know. I used to be in the cardboard and I just do it over and over. I used to have a free.
All right, we're going to factor first here. X squared minus 4x plus 3. How does it factor?
X minus 1 and X minus 3.
Very good. X minus 1 and X minus 3. We have 3 over X times X is X squared. What times what is negative 6? Negative 3 and a positive 2. So X minus 3 times X plus 2. And again, if you're unsure, always check the rainbow. And then 2 over X times X is X squared. What times what is negative 2?
Negative 2 and positive 1.
How about positive 2 and negative 1?
Oh yeah, I knew that.
Yeah, better? Okay. Okay, so now we're trying to get, oh wait, before we do that, what is X not allowed to be? 1, 3, and negative 2. X is not allowed to be a positive 1, a positive 3, or a negative 2. Good to pay attention to that for sure. All right, let's see. When I look for things in common, I see I have an X minus 1 and an X minus 1, which means my second fraction here also needs an X minus 1 on top and bottom. I see I have an X minus 3 and an X minus 3, which means I need another X minus 3 way over here. So now every fraction has a green factor. And then I have an X plus 2 and an X plus 2, and I see that my first fraction needs that X plus 2 on top and bottom. And so now every single fraction has a purple and a green and a pink factor. And now since all the denominators match, what can we do?
Forget them.
Forget them. Forget you. Okay. All right, so I'm left with 2x times the quantity x plus 2 plus 3 times the quantity x minus 1 equals 2 times the quantity x minus 3. And you're going to distribute. What do you get when you distribute your 2x?
2x squared.
2x squared plus 4x. Good. Distributing your 3, you get minus 3, 3x minus 3, good. And then distributing our 2.
2x minus 6.
Mm-hmm. Is this a linear or quadratic equation? It is quadratic, and so how do we go about solving a quadratic?
Yeah.
Set it equal to 0, and then factor or quadratic formula. Okay. All right, so I'm going to do a little cleanup first, I guess. 2x squared plus 7x minus 3 equals 2x minus 6. And then I'm going to go ahead and subtract my 2x, and I'm going to add my 6. So that gives me 2x squared plus 5x plus 3 is equal to 0. What do you want to do, quadratic formula or double bubble? Double bubble, you can factor this. Remember, you must check the rainbow. So first times first has to be the first thing. What times what is 2x squared? 2x times x. Very good. And then last times last has to be positive 3.
Plus 3 plus
1. Positive 3 and positive 1. And how do you know if you did it right?
check the rainbow.
Check the rainbow. Yeah, 2x times 1 is 2x, and 3 times x is 3x, and when we add those together, that's where that 5x comes from. Okay? All right, very good. And so then what do? Set each bubble equal to 0. So 2x plus 3 equals 0, and x plus 1 equals 0. That one's easy. X equals negative 1. And over here, what do we need to do? Subtract 3, divide by 2. Subtract 3, divide by 2. So negative 2/3. Are they both good solutions? Yes, they are both okay. Okay, ladies and gentlemen, do you have questions for me? This is fun. I love this stuff. It's great. There you go, ladies and gentlemen. Have fun.
Yay.
It's only 10
There's on the second document.
Okay.
Oh.
You say maybe? Yeah.
Oh.
Hey, that's a good Julie.
Oh.
Julie doesn't get you. Sorry, Julie.